Okay, we ever take another integral from the UNSW integration be 2024. This is problem number 6. We have the integral of this whole infinitely nested expression dx. Okay, I'm really noticing that these nested expressions can be kind of confusing. This is my second time recording. I kind of messed up the first one. Now, the thing we want to notice here, we want to kind of find out what's repeating and try to sort that out. It's hard to visualize these. Like one way I like to do, I like to kind of like break it up. Let's just kind of circle like this piece right here. Now it's infinitely repeating, so I'm going to do this. I'm going to call this thing y. But then we have the situation that this thing right here, this thing over here, if we circle this like wider expression, this isn't the exact same form. You know, it looks a little different because the way we're showing the repeat, but this is actually the same thing. This piece here, this is actually going to be y as well. And then what I can do for the bigger expression, I'm going to kind of just create another one of these. If I just add a 2 in front here, then actually our whole integral, this whole thing, this is all y. But of course, you're not just able to add a 2 for no reason, so I'm going to subtract off the 2 just so I'm not changing the integral. But now that we have it where our whole integral is y, what I want to do is create another expression. I want to solve for y in terms of x, and then hopefully we've got something simpler that we can actually integrate rather than this whole big mess. So then we'll come over here to rewrite this. We're saying everything's y. We're saying everything's y. I got the 2 up front. This is going to become 2 plus x in the numerator. And then again, this whole thing in the denominator, this is all going to be y. And then let's just multiply both sides by y, multiply by y over here on the right. And then let's see what we have. This is going to become, we end up with y squared on the left. Multiplying in here, we end up with 2y. Y's are going to cancel here, and we're going to get a plus x. I want to get everything back on the left side here, just so that I can make this into a quadratic in y. So what's going to become, we're going to have y squared minus 2y minus x equal to 0. And then from here, let's just solve this using the quadratic formula. We're solving for y, keep in mind, like x is not, x in this case, we're considering like a constant. So like this x in the quadratic formula, this is going to be like our c value. Our b value is going to be minus 2 over here, and we're going to have like a 1 for our a value right there. So putting together our quadratic formula, solving for y, we're going to have minus b out front. So minus this is going to be a 2, plus or minus b squared is just going to be 4, minus 4, a, which is 1, c again is minus x, and then this is all going to be over 2a, or just 2. Minus times minus is plus here. Then what I can do if I have some space is I can actually factor a 4 out, and then when we take it outside the radical, this is going to become plus or minus 2. Then we're going to have the square. This whole thing is going to reduce to just 1 plus x all over 2, but then I can cancel 2's everywhere. And so all this boils down to just 1 plus or minus square root 1 plus x for the y value. Now the trouble we have is we don't really like having plus or minus here, so we like to get rid of that. It's tempting to just drop the minus, but you will notice if you have certain x values, you could still have a positive value with the negative there. Like I think if x is like minus a half, this whole thing is still going to be greater than 0. So we actually have to leave this. We have to leave the plus or minus in there for this case. But now I can just take what we found here, put this back in for y, put this back in our integral. We'll just integrate and finish it off. Okay, so now we've taken this y value, filled it into our integral. I have this minus 2 that we brought down here. Now, of course, 1 minus 2, I can combine those together. Let's get rid of the 1 and write this over here. That's just a minus 1. And one other thing I can do here, let's just get rid of this radical and write it. Let's write it with this notation, write it as 1/2, because I'm just going to use power rule on this. We don't need to make a u substitution because the derivative is just going to be 1 dx. So we'll just go ahead with this, integrating, keeping the plus minus. We have the plus minus, 1 plus x, power rule, this is going to become 3/2. Take the reciprocal, we have 2/3 up front. This becomes minus x, add a plus c, and that's it. Okay, we don't really like having plus minus on there, but sometimes that's life. Okay, there you have it. Interesting one from UNSW 2024. Thanks everyone for watching. Have a good day.